In this video, we will talk about the pair t-test for means. So think about this t-test as the dependent t-test for means. So if you saw the previous video, in the previous video, we talked about the independent sample means t-test. And here we're going to do the pair t-test. So this was independent, this is for dependent samples. So imagine if you want to know whether you should be using this test. Well, this test is when you have something called matched pairs, okay, that are dependent observations, okay, so they depend on one another. You can think of pre-post data. So if you're looking at something that you did before and then something that you did after, or maybe if you took an exam and then you did a makeup, see if there's a comparison between those two tests. But you're basically doing it on one particular person, so on one subject, so it's being applied to an observational unit. Okay, so you're doing it on one particular thing, and you're doing, for those people, you're doing it twice. Think about it that way. So one of the things that you need matched pairs, you need some sort of normality, you need no outliers, and you need continuous data. Okay, so let's first start off by writing down our null and our alternative. Okay, so let's start off by writing our HO and our HA and HA. Okay, the way that you're going to write this is going to be the mean difference, mean sub D is equal to 0, and then mean sub D is not equal to 0. Here, mu sub D is just equal to the mean difference, okay, among the groups. So basically, if you think about it, let's say I gave 2 exams, okay, to kind of see if they did better or not. Okay, so let's say this is exam 1, and here is exam 1, and then they did a makeup. Okay, and then I had a couple scores, like, let's just say it's 46, 78, I don't know, 40. Let's just say that we had that. And then they did the makeup and they got like a 50, 84, 74. So basically what you're doing is that you're subtracting these differences. Okay, so you're going to get your first difference, difference number 1, another difference, and another difference. You're going to add them up, divide it by 3, and you're going to get your mean difference, which is actually x bar d. Okay, so you're saying here, when you say mu sub d is equal to 0, that means that there's no difference. So the fact that you did a makeup made no difference at all. Okay, so, and then HA means that whatever treatment you did, it actually is working. The follow-up was probably better. Okay, so that's basically what you want to do. So make sure that you have this matched pairs, normality, no outliers, and continuous data. Okay, so now let's go ahead and look at my at Statcrunch. Now here, what I did is I wrote down a couple of extra variables. Exam 3, here are some scores. Exam 3 makeup, here are another scores. Okay, so the first thing that you want to check, if you go back to the assumptions, you want to check for matched pairs. Obviously, these are going to be matched because I'm doing it on the same amount of students, okay, the same subjects. I'm giving them exam 3, and then I'm giving them exam 3 makeup. So they're matched. Normality, I don't know if I have normality, so let's just check. So you can either do a histogram if you want, or you can just do a QQ plot. Let's just do QQ plot. So let's click on exam 3 and exam 2. Let's see, can I do this? Would it let me do this? Okay, so I'm gonna highlight both of them. And then here, this one, you can kind of see that they're kind of on the line. They're kind of close to the line. These two, I'm not sure, but they're somewhere in there. And then these, same thing. Okay, so you can kind of see maybe there's a little bit of normality. I'm not sure, but we don't have a lot of data. Okay, so yeah, we don't have a lot of data. But let's just say that we're probably not. It's probably not as normal. They're not on the line, so you want to say that in your project. Okay, so we checked matched pairs, they're definitely matched. Normality, kinda. Okay, looking at the QQ plots. Outliers, there might be some outliers, especially this person who got a 12. this person who got a 25. Okay, so these guys might be outliers. Okay, so maybe you can decide to do whatever you want with them. Continuous data, well, it's kind of discrete, but we can assume that people can score like an 85.3. We can get decimals, so you're good. All right, so now how do you do this? How do you test it? So let's say all of our assumptions were good. Okay, so we just put checks. Um, what do we do? So what you want to do is you want to click on stat, then you're going to click on T stats, and then you're going to click on paired, okay, because you're pairing them. Sample number 1 is going to be exam number 3. Okay, that was before. And then sample number 2 is going to be exam 3 makeup. Then you can see here mu d is going to be 0. Mu sub d is not going to be equal to 0. If you ever think that is on one direction, you can change it. And then let's press compute. So then this is what you want to be able to save and copy and paste on your research project. Here you have the mean error, which is -5. You have a p-value, it's kind of high, so I'm not sure if it really made a difference. And actually, you can even see here that they're kind of around the same. Nothing really happened. So, I mean, to some of them, maybe this guy did worse. I don't know. Basically, you want to make sure that this guy is as further away as possible. But, I mean, this is what we basically got. So, again, is this believable? Probably not, because if you look at our assumptions, we did have a couple of outliers, and then we maybe don't have the normality assumption. So should we believe this p-value? Probably not, just because of our assumptions, they probably were not satisfied. So all of this, make sure that you put into your paper if you use this test.